All right, so now, so I have my setup now, and now what can I do? Well, I claim that I can still do cover-up for A. It's the same idea. I cover this guy up, and if I really multiply by it, it would knock everything out but A. So I cover this up, and I plug in x equals 1. So I get here 1 squared divided by 1 squared plus 1 is equal to A. In other words, A is equal to 1/2. Again, cover-up is pretty fast, as you can see. It's not too bad. Now, at this next stage, I want to find B and C, and the best idea is the slow way here. It's not too terrible, but it's just what we're going to do, which is to clear the denominators completely. So for B and C, just clear the denominator. That means multiply through by that whole business. Now, when you do that, on the left-hand side, you're going to get x squared, because I got rid of the whole denominator. On the right-hand side, when I bring this up, the x minus 1 will cancel with this. So the A term will be A times x squared plus 1. And the bx plus c term will have a remaining factor of x minus 1, because the x squared plus 1 will cancel. Again, the arithmetic here is not too terrible. Now, I'm going to do the following. I'm going to look at the x squared term on the left-hand side and the right-hand side. And that will give me one equation for B and C, and then I'm going to do the same thing with another term. The x squared term on the left-hand side, the coefficient is 1. It's 1 times x squared. On the other side, it's A, but remember, I actually have A. So I'm going to put it in, it's 1/2. All right, so this is the A term. And so I get 1/2 times x squared. And then the only other x squared is when this bx multiplies this x. So bx times x is bx squared. So this is the other coefficient on x squared is b. And that forces b to be 1/2. And last of all, I'm going to do the x to the 0 power term, or otherwise known as the constant term. And on the left-hand side, the constant term is 0. There is no constant term. On the right-hand side, there's a constant term 1/2 times 1. That's 1/2 here. And then there's another constant term, which is this constant times this minus 1, which is minus c. And so the conclusion here is that c is equal to 1/2. Another question, yeah?
So I assume that if you multiply it out, however, and you didn't have an x term, you would put that in like an x to the first power, but since there's an x to the first power, it's just assumed to be 0, right?
There's also an x to the 0 power hidden in there, here. I mean, sorry, an x to the 1 power. That's what you were asking about. Sorry. There's also an x to the 1 power. The only reason why I didn't go to the x to the 1 power is that it turns out with these two, I didn't need it. The other thing is that by experience, I know that the extreme ends of the multiplication are the easiest ends. And the middle terms have tons of cross terms. And so I don't like the middle term as much because it always involves more arithmetic. So I stick to the lowest and the highest terms if I can. So that was really a sneaky thing. I did that without saying anything. Yes?
You just set x equal to 0.
Another good question. Could I just set x equals 0? Absolutely. In fact, that's equivalent to picking out the x to the 0 term. And you could plug in numbers if you wanted. That's another way of doing this besides doing that. So you can also plug in numbers. Can plug in numbers. X equals 0. Actually, not x equals 1, right? Minus 1, 2, etc. Not 1 just because we've already used it. We won't get interesting information out. Yes?